Hey there, everybody. It's Jacob here, back for week 2, day 2 content. And today we are going to be going over the 3 contracts, Kibble, KittyItems, and KittyItemsMarket, that's in the project that you downloaded off of DAppStarter yesterday using the Fast Floward Foundation. So you're probably wondering what any of these KittyItems or Kibble means, and hopefully this video will answer that along with how it's implemented at the contract level with these 3 contracts. So in this video, we're not going to be going over any of the transactions, any of the scripts, or any of the JavaScript or front end that actually gets our dApp running, which you saw yesterday in one of the quests. All we're going to be doing is going through these 3 contracts. And so before we even start, I kind of want to give you a project overview of what KittyItems even means. So KittyItems is a popular example in the Flow ecosystem, and it's usually used a lot by the Flow team to help developers who are interested in Cadence get to know the Cadence programming language and the Flow blockchain in general. And so I've sort of laid out a simple example of what the KittyItems looks like in our Fast Floward Foundation, and I've modified the KittyItems project a lot because I wanted to make it more understandable for you guys. And also I believe that, if I slapped comments everywhere, hopefully it would help you understand. So this is kind of a simple project overview. So the Kibble contract, what Kibble is it's a fungible token or a currency. And we are going to be using this Kibble in our marketplace. So our marketplace is going to be selling KittyItems. And the way that we will buy KittyItems is with Kibble. So you can think of Kibble as the sort of currency or money, and KittyItems is like the value or the item that we will be buying and trading back and forth. So if you think back to the picture example with Morgan last week, you can think of KittyItems almost as the picture resource, and we will be selling the KittyItems on the KittyItems marketplace. So to kind of go over these a little more in depth, Kibble has 2 main things: a vault resource, which holds Kibble, and a minter resource, which mints Kibble. And we will go over exactly what these 2 mean. So you'll notice that there's no like Kibble resource or anything like that. Kibble is represented simply by a UFIX64, so a number. And it's passed around in vaults, and we will go over this in a second. So KittyItems, which are the marketplace items or the value here, has 3 main things as well: an NFT resource that represents a KittyItem, so we will use NFT and KittyItem interchangeably; a collection resource that holds KittyItems or NFTs, so it stores NFTs; and then an NFT minter resource that mints NFTs, so this will mint the KittyItems or the NFT resource. And then lastly, this is our marketplace, the KittyItems marketplace contract, and this has 1 main thing, and it's called a sale collection resource. And this sale collection resource holds a dictionary that maps an NFT ID to the price for that NFT. So what this means is it'll map an NFT ID that's probably defined in this resource right here, and it'll put a price of Kibble, so the amount of Kibble it will take to buy that. So it allows users to purchase from this sale collection by providing enough Kibble. And when purchasing, the contract looks into the NFT owner's NFT collection, so this right here, takes the NFT out and gives it to the buyer. So this is a simple project overview of what KittyItems looks like. So let's actually dive into the code and see how this is implemented. First, we're going to be looking at Kibble, which is the fungible token. And to start off, if you remember from the contract interfaces video from yesterday, the reason why I wanted to go over that was because of stuff like this, where you can see that Kibble is implementing the fungible token interface, and you can actually find that online. If you go to the Flow team's GitHub page, you can find the fungible token interface defined. And so this is just making sure that our Kibble meets the fungible token requirements. So to start off, there's a bunch of events here, and we won't go over these too in depth, but all these are doing is sending out events to our client when stuff like this happens. So when we initialize tokens, or when we withdraw tokens from our vault, or when we deposit tokens into our vault, maybe when we create a minter, these are all events that will get broadcasted. And so this isn't too important, but in your implementation, you will have to emit these events, but I've specified where you have to do that, and we will get into that soon. So you've probably seen events, and this is just what they are in the Kibble contract. Next, we have a bunch of named paths, and I want to kind of skip over this for now because I will come back to this in a second. So here we kind of start getting into the important stuff. So we have a total supply, which is a UFIX64, and these are all the total supply of kibbles in existence. So you'll see that throughout these contracts, there's a crap ton of comments, and that's on purpose, and that's to hopefully get you to understand these. If you find this video boring, you can, of course, just read these comments, or hopefully these will help you even after the video is over to give you some extra information. So then we get into a vault, and this vault implements 3 interfaces that are defined in that contract interface. So hopefully all this is coming back to you from yesterday and last week with Morgan. So it implements a fungible token provider, a fungible token receiver, and a fungible token.balance. And what these 3 specify pretty simply is fungible token makes sure, fungible token.provider makes sure that we have a withdraw function, fungible token.receiver makes sure that we have a deposit function down here, and fungible token.balance just makes sure that we expose this balance field to anyone that wants to read it. So this vault is going to be storing kibble. Now inside this vault, we have a balance. And so this is the total balance of this vault. So this number right here represents all the kibble that's in this vault. And, we can initialize, when we initialize this vault, we're just going to set balance to, whatever we pass in as balance here. So then we go down to withdraw. And this is one of the functions that you actually will have to implement in today's quest. So to make it easier for you, I've put comments here. And also I've put comments here describing exactly what you'll need to do. So for example, this says to do, delete the line below and implement this function. So you will delete this line, and then you're just going to go through each of these, and for each one of these comments, write the line of code. And so each one of these comments is only one line of code so that you don't get confused. So if you find yourself writing a bunch of code here on multiple lines, then you've done something wrong. It only takes one line of code for each comment. And so hopefully that will help you go through these examples much easier. So next, we have a deposit function. And this deposits a fungible token.vault into this collection. So somebody that wants to give us kibble will have to give us a vault, and we will take the kibble out of this vault and put it into our own. And so you will also have to implement this deposit function. Then we have a destroy, which simply just destroys the kibble. So next we have a create empty vault, and this just returns a vault resource. So, much like the printer from last week, this is just creating a vault resource and returning it to the transaction or whoever called that transaction. And so this is just so that they can store kibble in their account. Lastly, we have the, public resource minter. And what this is just a resource called minter that only this contract account will have. So if you go down to the init function, you'll see that we're saving this minter to account storage. So no one else can get this minter except for this contract. And what this is going to define is a function called mint tokens that will take in an amount and return a kibble.vault that has that amount in it. So you will also have to implement this function. So for day 1, there's only 3 functions you have to implement, and I've commented them each here so that hopefully this will make more sense to you. And this is all of Kibble. Now, I told you that I would come back to the vault storage paths that we saw up here, these ones, the named paths. And what these are is these just defines paths that we can set as variable names so that in our transactions, we don't have to write /storage /help, or we don't have to write /public /I love Cadence and Jacob so much. No. So instead of this, all we have to do is just define a vault storage path, and then in our transaction, we can just say, kibble.vault storage path. And this will act as, this will act in place of this. And so that is a little helpful because it makes things more clear. So, we define total supply to 0 because there's no kibble initially. We save a minter to the account storage, and we emit tokens initialized. And that is it for the Kibble contract. So you can pause the video here maybe go over what I just said again, read the comments here, and hopefully this will make more sense. Now, I know I'm throwing a lot at you, and this is going to take a long time to understand, or for some of you it may be quicker, but for some of you it may take longer, and that's okay. But the point is that during this week, we will go through this contract together and these other two, and hopefully, learn more and more as we go on. So let's go to KittyItems now. So KittyItems is not a fungible token. It's a non-fungible token. And if you've heard of NFTs on the blockchain, they're essentially just, values or objects that are completely unique. And this is why cadence is so perfect, is because resources represent things that are unique. So our Kitty item will implement the non-fungible token contract interface. And you can actually see that if you go to this flow folder right here and go to non-fungible token, you'll see that I actually showed this in yesterday's video with non-fungible token contract interface. But you can go through this and see all of the things we've defined in this contract interface. And this is defined by the flow teams themselves. So that if anyone wants to have a non-fungible token, they have to use this contract interface. And so we've done this for KittyItems so that it's a true NFT. So in this contract, you can see we have a bunch of events here that I won't go over because this is relatively simple. Named paths, so similar to the Kibble contract. And then we start getting into the weeds here. So total supply is a UN64. This is the total number of Kitty items that have been minted. So if we mint 3 Kitty items, this total supply will be 3. We then have an NFT resource, so a public resource NFT, and this implements non-fungible token.inft. And if you don't understand this part, then I suggest going back to the contract interfaces video, because we did a very, very, very similar example to this before. If we go to non-fungible token, which is the contract interface, you'll see if we scroll down, it says a public resource interface INFT, and then a resource NFT that implements this INFT, and this has an ID field. So if we go back to KittyItems, you'll see this exact same thing here, where we have to define the NFT that implements non-fungible token.inft, and it has an ID field here. So we've also added our own thing, which is a type ID. And so when we think of a Kitty item, think of, hats or gloves or maybe a sword or a shield or boots or whatever it may be that we would put on our kitty. And so this whole example is coming from CryptoKitties, if you've heard of that. CryptoKitties was an old Flow project where people bought and sold kitties. And so this is just an extension of that, where it's unique items we can put on our kitty. And so that's what these type IDs represent. So then we have a public resource interface, Kitty items collection public. And, this part is really referencing Morgan's video from last week where we went over resource interfaces. And this just allows collection to implement this interface. And so this is saying that collection must have deposit, get IDs, borrow NFT, and borrow kitty item, which has a post condition on it, saying that the result, cannot be, or the result must be either nil, or the result, that ID must be the ID that we wanted to read. And so this is similar to what we were looking at yesterday during contract interfaces as well. So in our collection, we have owned NFTs, and this maps to the ID of an NFT to the NFT itself. So for example, if we have an NFT with ID 5, it's going to map an NFT with ID 5 to the NFT itself. So this would be 5, and this would be that NFT that has the ID of 5. Then withdraw, and withdraw takes in an ID, which will be this right here. So let's say 5, and it will return that non-fungible token. So it will take it out of this dictionary. So this should be similar to what we saw with stuff like pictures last week and the picture collection. Then we have deposit, which takes in, a token, which is a non-fungible token, NFT, and this just deposits this into our owned NFTs dictionary. Next, we have get IDs, and this just returns all the NFT IDs that are in our collection. Hint, you will be using this at some point. We have borrow NFT, and what this does is this just returns an NFT reference from our owned NFTs dictionary, so that we can maybe read some fields on it and stuff like that. But I will say that these two are probably not that important. If you're getting stuck on these, you can always ask me in the Burning Questions channel, but these two aren't that important. I would say that you're probably not going to be using these that much, but it is cool to understand how we can borrow references from a dictionary and return them so that maybe our script or transaction can read values from them. And borrow kitty item is very similar to borrow NFT, but instead of returning a non-fungible token.nft, we return a KittyItems.nft. And you might be thinking, well, what's the difference, right? Isn't an NFT the same thing as a kitty item? And the answer is, well, no, because non-fungible token.nft only has an ID field, right? If we go to non-fungible token and we look at NFT, it only has an ID field. But a KittyItems.nft actually implements that NFT that we just looked at, but it also defines a type ID that we can read. So if we have a KittyItems.nft, we can read both. All right, let's keep going. So then we have a create empty collection. All this does is return a non-fungible token.collection. An NFT minter. All this does is define a mint NFT function that takes in a recipient. So this is whoever wants this NFT or whoever we are minting this NFT to will pass in a non-fungible token.collection public, and it will deposit this NFT into the recipient account, or a type ID. And a type ID, and this type ID is like maybe 1, 2, 3, 4, whatever number it may be, and just think of those as mapping to like a sword, a shield, a hat, whatever it may be. Then I'm going to skip over fetch because this is kind of an irrelevant function. I honestly don't know why this is included in this contract, because you can simply just access a KittyItems NFT with this function here. So I'm not going to go over this because it's very confusing and you won't ever end up using this. But if you're curious, all it does is just gets a kitty item reference from someone's collection. Lastly, we have an init function here, and this just sets our named paths so we can use these in the transactions and scripts. And I will note that you will be using these a lot, during when I, have you writing transactions and scripts tomorrow. So then we have a self.totalSupply, which is 0. And lastly, we just store a NFT minter, which is also just mints kitty items to this account's storage, and then we emit contract initialized. So this is the KittyItems contract. And again, I really encourage you to maybe watch this video multiple times because I know I'm going through this very quickly, and it might be difficult to grasp at first. Yeah, I know it definitely was for me. But lastly, we're going to go over KittyItemsMarket. So KittyItemsMarket gets a little confusing because we start importing a lot of stuff here. And the reason we're doing this is because, well, we're using kitty items as our value or objects, and we're using Kibble as our currency. So we have to use both of these contracts. So inside KittyItemsMarket, we have a bunch of events that, are pretty self-explanatory. Something's for sale, NFT was purchased, now withdrawn. We have some named paths here. And then we start getting into the main, the bulk of this. So if we go back to our diagram here, you see that KittyItems Marketplace contract has a sale collection resource. And this is what we are looking at here. So a sale collection resource that implements sale public. And what sale public is this interface right here that defines, that says that this resource interface is saying that whatever implements this, which is sale collection, has to have a purchase function, which we do down here, right here. Then it says that we have to have an ID price and a get IDs. And we'll see that if we scroll down, that sale collection has both of those as well. So we've correctly implemented our resource interface. Now, what sale collection does is think of it as a almost like a personal marketplace for every account. So for whichever account wants to, sell their own kitty items, they have to have a sale collection. And what they can do is, they have the sale collection, and this sale collection stores 3 fields. And 2 of them may seem a little confusing because you're like, owner vault, that's storing a capability. What is that? And why is owner collection storing a capability? What does that mean? Well, what this means is, so when each person or each account gets a sale collection, they're going to pass in their Kibble vault that, is restricted by the fungible token receiver, so that this capability can only receive Kibble. It cannot give, only receive, because of this right here. and a owner collection. And this is a capability to the owner of this sale collection's Kitty Items collection. And so the reason we have these here is, if you haven't guessed already, it's because when we put our kitty items up for sale in this collection and someone buys from it, we will deposit into this capability that's already here and take the kitty item out of the owner collection, which is right here. And I'll show you how this works. So inside the list for sale function, we are specifying an item ID and a price. And so notice that when we list a kitty item for sale, we aren't actually passing in that kitty item to go to this sale collection. All we're doing is passing in the item ID that the kitty item has for sale and the price that it should be. And so in our list for sale function, we're saying that the price must be above 0, obviously, and we're using a precondition to do that. And then we're saying, inside owned NFTs, which is self.ownercollection.borrow.getIDs. So what this is if we scroll up to self.ownercollection right here, we're borrowing this capability and checking the IDs that it actually has. So what we're doing here is we're checking to see var owned NFTs self.collection.borrow.getIDs, if those IDs in the collection contains this item ID that we have here, then it's okay. So we can say, let's list it for sale and emit for sale. Now notice, if we had, let's say, kitty items with ID 0 and 1 in our collection, and we try to list a kitty item with item ID of 2, this would not work, right? It would not list it for sale because we don't have it. So when we go down to purchase here, you'll see we pass in an item ID we want to purchase, a recipient, which is simply a KittyItems.collection, right? And so this is so that when this recipient buys the kitty item, we'll deposit into this reference, and buy tokens. And buy tokens is a vault. So the buyer will have to pass in a fungible token.vault, which we can get in the Kibble contract by going to your vault and doing .withdraw. Notice that this is a fungible token.vault, and then pass that in here as buy tokens. And so in purchase, we're checking buy tokens.isInstance. We can use this as a pre-check of type Kibble.vault. So we're making sure that this buy tokens, which we specify as a fungible token.vault, because that's what Kibble returns when we withdraw, we're saying, okay, make sure that this is a Kibble.vault, not a flow token or any other fungible token. Then we're saying, make sure that the item is actually up for sale, and then make sure the buy tokens, which is the vault we passed in, has a balance that's greater than the price of this kitty item. So that meaning we've passed in enough to buy it. So let's scroll down a bit. This is the price of the kitty item. This is the vault ref. So we're borrowing self.ownervault.borrow. And what's owner vault? Let's scroll back up. Owner vault is the owner of the sale collection's Kibble vault, so that we can deposit the buy tokens into here. And let's see that happen. So vaultref.deposit the buy tokens, and then we're going to remove the kitty item from the person's collection. And so this is very crucial. So we never went into the person's, or at least the person who owns this sale collection, they didn't pass in the kitty item for sale, right? They just passed in an ID that we saw up here. So where does this actual withdraw step happen? When are we actually taking the kitty item out of the collection? Right here. This is when we're withdrawing the kitty item from the self.owner's kitty item collection that we defined right here. So, and then we're unlisting the sale because we purchased it. And also here, we're depositing this token, or this is also a kitty item, into the recipient's NFT or kitty items collection here. Then we just have two simple functions. One's called ID price, one's called get IDs, and these just return information about, some kitty items that are up for sale, which one's for sale, how much does it cost, stuff like that. And then we're going to create a sale collection, or this function is called create sale collection. And what this does is, if we go back up to our sale collection, it has three things: for sale right here, an owner vault, and an owner collection. And so if we scroll down here, you'll notice that we actually have to initialize these things, right? We have to pass in the owner vault and pass in the owner collection as well. And then we can simply set them here in the init function. Lastly, we just set some named paths, and this concludes the review for the 3 contracts. Now, I know I've said this multiple times at this point, but this is going to be a lot to take in, and I don't expect anybody to be able to understand all 3 of these contracts right off the bat, which is why all of your week 2, day 2 quests are only going to be in Kibble. So I'm trying to get you to understand what Kibble does by having you implement 3 functions: withdraw, deposit, and then mint tokens. And hopefully this will help you understand Kibble, which will then help you understand these 2. And once you get a basic idea of these 3, then you're really set. But I still don't expect you to have a full understanding of all 3 of these contracts, even by the end of the week. I just want to introduce them to you so that hopefully throughout this week we can learn it together, and so that you can ask a bunch of questions, either DM me or in the Burning Questions channel. Other than that, this concludes the contract review. And when you're doing the quests for today, make sure that when you go through these comments that I wrote, each line that corresponds to this comment, for example, add a precondition, that is just one line, right? Or, I mean, in this case, a precondition will be multiple lines just because of how it looks. But, for example, when we update Kibble.totalSupply, make sure that this is just one line of code that you write here. Make sure that it's not multiple lines of code that you're writing, everywhere. So, good luck in your quests, and if you have questions, of course, feel free to ask. Thank you.